Okay, last question of week 14. We have a concave lens. Okay, concave lens is made of glass. So this is the material of the lens with refractive index of 1.6 and radii of curvature. So when it says here radii, it means that we have two radius. Okay, R1 and R2. An object is located 30 cm from the lens. So first, before we do the question, bear in your mind we have concave lens. So this is the form, how a concave lens looks like. Okay, so we want to get the focal length, f for the lens. So in this question, we are not applying lens equation, okay, because we don't have the v. We have u but we don't have v. Okay, then what can we do here is we are applying lens maker's equation, plus it is given here in the question we have material of, we have n for the lens material, so we are applying 1 over f is equal to index of refraction for the material, lens material, over n medium minus 1 over R1 minus 1 over R2. So the part that we need to be more careful is the sign convention for both R1 and R2. So remember, let's say our light is coming from the left, so this is our R1. So your R1 here is seen concave, so its R supposed to be negative. And for the second surface, your R2, so it is seen convex. Okay, from the left it is seen convex, so your R is supposed to be positive. Now we do the substitution. 1 over f is equal to 1.6 over 1, assuming it is in air, because it does not mention any medium. 1 over 6 minus 1 over 4, positive 6, positive 4, then your focal length is supposed to be negative 4 cm. So by looking at this answer, your f is negative. It is again proving that it is, your case is about, okay, it's dealing with concave lens. For B, we want to get the characteristic of image, two characteristic of image, by doing the sketching of the ray diagram. So for this question, we need to do the drawing. So you should have your ruler. Okay, as usual, we draw our principal axis as the first step. So this is our principal axis. Then we draw our concave lens, the line at the middle, okay, of the lens. Okay, so you can draw it properly, better than mine. And then we have for your, let's say this is our focal point at the front, at the back and at the front. Okay, focal point. Our focal length is 4 cm. Okay, so let's say this is 4. So our object might be here. So this is our object, the position of our object, 30 cm. Okay, from the length. So bear in your mind, our object is 30 cm. So this is our object O. So what we do here is we have two possible ray. First, it will go straight parallel to the principal axis. Will go straight parallel to principal axis. Then it will be refracted. Then it will be refracted through the focal point at the back of the lens. Okay, so at the back of the lens. So this is your line. Okay, so the first ray must have arrow. Then the second one is it goes straight from the top of the object, it goes straight to the center of lens. So this is your second ray. Okay, remove your ruler, then you can see here that this is your image. Okay, so I put it in pink, so this is your image. So here you can see that your image is real because it is formed at the back of the lens, and if it is real it must be inverted. So here is the twin characteristic, and you can see clearly that the image is diminished. So at least you can have diminished two out of these three characteristics. So that's all for this week. Thank you very much.